All right, I'm going to cover some exponential function examples in this video. Just a quick reminder to find the factor. So this is to find the factor. You divide by the number before in the table. Then you take the root and let the index be what x increased by. So I'm going to divide 32 by 2. And I have my calculator open so you can see exactly what I'm doing. So I'm going to do 32 divided by 2, which is 16. And then I'm going to take the root of 16, and I'm going to let the index, which is the small number inside, be what x increased by. So x went up by 4, so I'm taking the fourth root of 16, which in Desmos you use this key for, fourth root of 16, which is 2. So the factor of this table is 2. So let's look at a couple examples on page 24 and 25. So here I think this is probably exponential because it's increasing rapidly. But let's find the factor for a couple of these. So I divide by what came before. So b is going to be the factor. I'm going to divide by 8 and I get 25. X increased by 2, so I'm going to take the square root of 25, which is 5. Let's see here. If I divide 5,000 by 200, so divide by what came before, and then x increased by 2, so I'm going to take the square root of 25, which is 5. And then I divide by what came before, again, so 25,000 divided by 5,000 is 5, and that's the factor because x increased only by 1 here. When x increases by 1, you don't take the square root. So I got b is 5, so this is exponential because there's a common growth factor. So b is 5. All right, the next one I think is probably linear because it's not increasing very quickly. So let's see if we can find the rate of change. So y subtracted 3, x added 1. So to calculate the rate of change, you do change in y over change in x. So the rate of change is -1. Then I subtracted 2, I added 2, and so the rate of change is -2 over 2, -1. Went down by 1, went up by 1, the rate of change is -1. So this is linear because m, the rate of change, is -1. All right, so these next ones, I am going to write the exponential function. So these are exponential. So the parameters for exponential are a and b. A is the initial value, b is the factor, what you're multiplying by. So I like this first table because it gave me a. A was 5. I need to calculate b. So to calculate b, I divide by what came before. So, excuse me, 9 is what I multiplied by, but the index needs to be 2 because x increased by 2. So I'm going to take the square root of 9, which is 3. So b is 3. And I would get that if I did the same process with the rest of them, but I know it's going to be exponential, so I'm just going to leave it. And so 5 times 3 to the x power is my function because I'm filling the parameters into the formula for an exponential, which is a times b to the x. All right, so this next one did not give me a, which means I need to find b first to be able to work backwards to find what the initial value is at 0. So I'm going to divide by what came before. So I'm going to do 48 divided by 12, which is 4. Now x increased by 1, so I don't have to take the root of that. That just tells me my factor is 4. So to go back and see what matches with 0, I'm going to divide by 4. I'm going to do 12 divided by 4, which is 3. So the initial value had to be 3 because 3 times 4 would have given me 12. So f of x equals a times b to the x. A was 3, b was 4 to the x power. Now I could check this. Let's pick 4 to plug in for x. 3 times 4 to the 4th should be 768. Let's see. 3 times 4 raised to the 4th power is 768. So this is the correct function. All right, let's do the 2 odd problems here. So to write an exponential function, I need to know a and I need to know b. So they don't give me either here. So I'm going to divide backwards. So I'm going to divide 16 by 0.25 to find the factor. And so I multiplied by 64, but x increased by 3, which means I need to take the third root of 64. My index is 3 because that's what x increased by. And so b is 4. So to find a is at 0. So if I was at -1 and I had to get to 0, I need to move forward in the table by 4. So I'm going to multiply 0.25. I'm going to multiply that by 4. Multiplying that by 4 brings me to 0. 0.25 times 4 is 1, so a is 1. So the rule is f of x equals 1 times 4 to the x, but you don't really need to write times 1, so it's just 4 to the x. F of 10 means I'm going to plug in 10 for x. This is going to be a pretty big number, I think, because anything raised to the 10th power gives us a pretty big number, which it is. It's 1,048,576. If I raise it to the -3rd power, I know that's going to give me a fraction. Desmos, by hitting this button, gives me a fraction, which is much nicer than that long decimal I just got. So this button gives me the fraction form, which makes sense because anything raised to a negative power is always the reciprocal. So it's 1/4 to the 3rd. That kind of makes sense. All right, number 11 I like because it gives me the initial value. And so now I need to just find b by dividing backwards. So I'm going to divide 81 by 3, and that's 27. But because x increased by 3, I need to take the cube root of 27, which is 3. So my function is f of x equals 3 times 3 to the x. F of 0, I don't even need to plug it in. I already know it. It's right here in my table. F to the 0 is just 3. Then to find f of 2, I do 3 times 3 to the 2nd. 3 times 3 to the 2nd, which is 27. So once I have the rule, all I do is plug in the value to evaluate it.